Hello everyone, I'm Bingja. Welcome back to another video. So in this video, we're going to be starting to go into chapter 4, and just to check whether my mic is okay, it's not muted. All right, so in chapter 4 we'll be looking at a lot of angles problem. All right, so alternate angles, corresponding angles, how to look for an angle in a circle, cyclic quadrilateral, and so on. So in this video it's more on the theory side, like the names of angles, properties of angles, and so on. So without further ado, I'm gonna write down the agenda for today. So for the first one, we are gonna be looking at no, not too light. Okay, different name of angles, name of angles. Yeah, I don't know. Okay, so number two. After that, I have to mention in the syllabus there is like draw lines or triangles using the protractor. Sorry, using the compass. Using compass, and number three is scale drawing. And I have to mention that I am not covering this two. All right, I am not covering here because I cannot show. It's hard to show on PC. All right, so these two you will have to really listen to your teachers carefully. If you don't understand anything, you must ask them to explain, because this actually costs around 4 to 6 marks during my time. All right, and it's quite important, so make sure that you know this too, because I will not be covering this in my IGCSE Maths videos here. All right, so uh, after that, in this video, we will continue on uh, similar triangles. All right, areas and volumes. After that, number three, we'll be learning about congruence. All right, there's a difference between congruence and similarity. So yeah, let's jump straight into the first agenda for today. Okay, so number one here, there are different type of angles. All right, so number one, we have angles. We will usually denote it as theta. Okay, this is theta, theta. All right, so this is usually when we are talking about an angle, then we will say about theta. All right, so the first one we have here is angle like this. All right, which is angles from 0 to 90. I actually shouldn't include the equality sign. Okay, 0, theta, 90 degrees. This is called the acute angle. All right, so you have a very acute angle here, which is lesser than 90 degrees but more than 0. It's called the acute angle. All right, I will add a little degrees right here. Okay, so the first one is acute angle. Number two, we will have the right angle. All right, so the angle is just right, that it is just 90 degrees. All right, theta is equals to 90 degrees. So this is called a right angle. Okay, so after that, we will have an obtuse angle. All right, an obtuse angle is an angle which is more than 90 degrees but less than 180 degrees. All right, this is called an obtuse angle. After that, you will have a straight line, all right, which is a flat line, and we call it theta equals to 180 degrees, and it is just a normal straight line. Alright, there's no definition actually if you don't want to include this in your glossary for angles, but it is good to know that a straight line is 180 degrees. Alright, so after that, we will have a reflex angle. Alright, reflex angle. Okay, so reflex angle are angles larger than 180 degrees but lesser than 360 degrees. So these are called reflex angle. Okay, and last but not least, you will have a whole circle. Okay, you will have a whole circle. It's off-centered, damn it. Okay, it's still ugly, but the whole circle, theta equals to 360 degrees, it is just a circle. Okay, so these are the very basic angles, name of angles that you will need to know. And yeah, this is all about the introduction to the angles. Number two, we will be talking about the name of shapes. All right, so we all know this is a triangle. All right, in fact, the tri here means three. All right, so you can see there are three sides here, three vertexes, and so on. Therefore, it's called a tri. All right, so in a triangle, just to mention here first, I'll probably mention it again in the future videos, has 180 degrees of interior angles. All right, it's just to mention it now, and it's good to actually have a guide in your head saying that, oh, when you see a triangle, it's 180 degrees. Number two, maybe I would like to write down first. This have like the characteristics of a triangle: three sides, three vertices. Okay, and you have 180 degrees of interior angles. Number two, you will have something that has, you might say this is a rectangle. Okay, if you draw all the sides are equals, it will be a square. However, we have a general name for shapes that have characteristics of four, which is called the quadrilateral. All right, quadrilateral. Okay, and if I'm not mistaken, the quad has the meaning of four. All right, hopefully it's correct. If not, I'm just gonna cancel this part. All right, so yeah, very good thing to know. The quadrilateral have 360 degrees of interior, and we will actually prove this in the future video. Yeah, in the next one or two videos on coming. So quadrilateral have four sides, four vertices. All right, so quadrilateral can a square is a quadrilateral. A rectangle is also a quadrilateral, and even something like something as ugly as this thing right here that you probably say you can't name any of these, it's also a quadrilateral. In fact, a kite is also a type of is the kite a quadrilateral? I have to double check on this and I will come back. Okay, so these two are the things that I will need to. Okay, and number three is the, hey, why are you not moving? Okay, number three here is a circle. All right, it's pretty much a perfect circle, isn't it? Circle. Okay, circle have also, all right, in fact 360 degrees in the angles inside. All right, so you might have seen a meme saying that a square is a circle because they have the same 360 degrees of interior angles. However, this is not the case because visually it's different and mathematically it's different too. All right, so a circle have infinite sides and infinite vertices. And in fact, I'm going to introduce to you the different names of a circle. So I'm going to be erasing all this and I'll draw a way larger circle. Okay, so Okay, I have made them produce a circle for me from this smart sketcher here. So in the center here, we have the center point of a circle. All right. And if we are going to draw a straight line right here from the center to the outside this part, we call it the circumference. All right. So this big thing right here is the circumference. Okay. And this line in the middle is called the radius. And this line right here cutting through the middle point, okay, cutting through the middle point and touching both circumference, it's called the diameter. All right. And if we are going to be drawing a line right here connecting two parts of the radius, it is actually still ugly. Wait a second. I am going to draw this. Okay, nice. This is called a chord. Okay, so now we are on to the areas of a circle. So this area right here, okay, I'm gonna use a different color. This area right here is called as a segment. Okay, and these big things right here, okay, is called a sector. Okay, am I missing anything? Sector, segment, chord, and okay. And this line right here, this part, okay, maybe I should do the other side. All right. And this part, this lines right here is called the arc. Okay. Circumference, diameter, radius, chord, sector, segment, and the arc. All right. So this is all the names you need to know for a circle. Okay. And it's going to be proof useful to you in the future videos. So it's best that you actually know the characteristics and names of a circle right here and right now. Okay, so we are done with introducing the names of the different shapes. So now we are going to be moving to our second agenda for the day, which is similarities. Okay, so what is a similarity? Similarity is something that is similar by the name it suggests. Okay, you will have same angles, same number of sides, okay, but not necessary to have the same shape, same size. Yeah, same size. Okay, this is actually very important. All right, not necessary to be the same size, because if it does, then it will be it will be a different name. So for now, we'll be looking at similarities, and one of the most common thing that you will ever see in IGCSE Maths is similar triangles. I'm not kidding. You're going to be seeing at least one in one paper, so you better know what's a similar triangle. So I will give you an example right here. So let's say this is A and this is B. Okay, provided both of them are right angle triangles, and you know that you are also given that this angle and this angle is the same. This angle down here and this angle down here is the same. Since all the angles are the same and they have all the same number of sides, they are similar. But since their sides are different, the the their sides are different, so they are still similar, and they are not another name called congruence, but we will see that later on. All right, so what do you need to know about similar triangles? Okay, I'm going to be giving an example right here, so that we're going to be using the same example throughout this whole video. So for triangle A, it will be 3, 4, and 5. And the second triangle, triangle B right here, will have the length of let's say 12, 9, and let's say 15. Okay, so these two are similar triangles, but we will prove how they are similar triangles later on. Okay, so when we talk about similar triangles, meaning they have, if we say A and B are similar triangles, then we say they have similar sides, similar angles, and we can say they have a similar area, and last but not least, similar volume. But similar volumes are they are 3D, so it's not counted in this case. Okay, so what does these two triangles are similar mean? Oh, okay, so in the example here, we are given that, all right, these all are given. This triangle right here and this triangle right here is 3 and 4, and this is 12. All right, and you are going to look for the length of this this line right here, this side of the triangles. And then the questions say are similar. So what does, if the questions say that these two triangles are similar, how or what does this mean? Okay, this means that this angle right here, this angle right here is the same as this angle right here. Okay, and this angle right here is the same as this angle right here. Okay, it must be the same. Okay, so back to this, I should actually change this to same angles. Same angles. Okay, and just to, yeah, same angles, same number of sides, and so on. So how do you look for x given that these two triangles are similar? And there's one way to do it, which is by using the similar ratio. Okay, so the ratio of this triangle and this triangle, as you can see from this line, is 12 over 4. So you can see how the 12 is from this part of the triangle, this part of the triangle of the second triangle, divided by the first triangle. So it's 12 divided by 4. And it will be equals to, all right, x divided by 3. All right, so you see how is the ratio going on. All right, so this triangle, the length of this triangle here is how many times of this triangle. So which means the other side right here will have the same similar properties, similar length, okay, at this side of the triangles. So if you do this, you will get x is equals to 9, and it is the same from what we get here. All right, which proves that these two are indeed a similar triangle. Okay, so after you get the value of 9 here, so you now know that x is equals to 9. Why is the color change back? 9. Then by using the Pythagoras theorem, you can easily find that 3 squared plus 4 squared is equals to 25. So if you square root it, it will be 5 right here. And if you are using the same method, okay, to look for it, then you can get the answer here to be 15. And indeed, if you use 9 square plus 12 square, it will be equals to 15 square. So these are the properties of similar triangles. So now we are going to be going on to similar areas, because similar triangles will have similar areas, but in a different way. Okay, so what is different here? So we know that the ratio is triangle B over triangle A. All right, and let's denote it as K. Okay, so K is the ratio between these two triangles. Okay, so if you are just looking for side, okay, you are just going to use the ratio K. So if from the example above, from the EG above, you will get the k is equals to 12 over 4, which is equals to 3. Therefore, you know that x over 3 must be equals to 3, which gives you x equals to 9. All right, easy, no problem. But for areas, all right, for areas, there's something that you will need to be aware of is, for areas, the ratio will be k squared. Okay, why is it k squared? Because if we recall, the formula for area is length multiplied with height. So as you can see, when a triangle becomes larger, they increase in both ways. All right, which means the ratio to be increased is not just k. It must be k multiplied with k, which is k squared. All right, so if you don't really understand this, I must apologize that I cannot describe any more clearer, because this is how I understand it to be. You just need to memorize it as, if it's area, then its length multiplied with height, then it must be k squared. Okay, same goes to volume. If it's volume, then it's k cubed. All right, it's just like that you need to memorize this. Okay, so we're gonna prove that this k square here actually works for the area of triangles. So if we're gonna look back up here, okay, let's erase this volume first. I'm gonna include it at the last line. Okay, area of A is 1 over 2, 3 multiplied with 4, which is equals to 6 units square. All right, so now you can simply know that the area of B is equals to 1 over 2, 9 times 9 times 12, which is equals to 54 units square. All right, however, if you're not given the sides of the second triangle, but you are given the ratio for the similar triangles, then you can say the area of B is equals to k square the area of A. All right, it's just that easy. And k in this case is, if you can see right here, the k is that we found earlier is 3. Therefore, it's just 9 multiplied with the area of A, which is 6. Then it is equal to 54 units square. All right, so it actually proves, because these two is the same, so you can use the similar method if and only if the triangles are similar. All right, so this is one of the properties of a area, the similar triangles. All right, and just a quick one, I'm going to include for volume down here is equals to k cubed. So if you have meet similar cubes, let's say, if you are given a cube with side 2 and a cube with side 3, let's say, then the first cube will have the volume of 2 cubed, all right, and 3 divided by 2 is 1.5. If you cube it, times 8 will be 27, which is the volume of a cube. Actually, you know what, I'm just going to write it on the next page. Okay, right here. So given that this is a cube, okay, this is a cube of sides 2, and this is a cube of side 3. Okay, the volume of let's say this is C and this is D. C is 2 cube, which is equals to 8. Okay, and let's find the ratio between these two cubes are 3 over 2. Okay, it's just 3 over 2, because this ratio right here divided by this length right here. So as I said just now, since when the size of the cube increases, they increase in 3 ways: 1, 2, and 3. Therefore, you must use it as k cube. Okay, this is k, and therefore k cube is equals to 27 over 8. Okay, And therefore, you can say the volume of D is equals to K cubed, the volume of C, which is equals to 27 divided by 8 multiplied with 8. You will get 27 units cubed. Okay, so if you're going to double check with the original formula that you know, the volume of D is equals to 3 cubed, and it's 27 units cubed. All right, no issue. All right, so this is how you use the ratio k squared and k cubed for similar shape properties. Okay, so we are going to be moving on to our last agenda for today. Hopefully this video is not too long. Okay, the last part here is just congruence. Okay, versus similarity. Okay, so what are the difference between congruence and similar? So we said just now they must have I need the green one, same angles. Similar have same angles, and same number of sides. Okay, same number of sides. However, if you remember that I said that one property that defines a different name, which is not necessary to have same length of each side, right? If you look back there, 3, 4, 5 and 9, 12, 15 are definitely not the same. Therefore, they are only similar, but they are not congruent. However, for shapes to be congruent, you must have same length of each side. That is technically, there is a symbol for congruence is this wavy up there and an equal down there. All right, so when two shapes are the same, then they are congruent to each other. All right, and I'm just gonna be listing down whatever is stated from the syllabus that you will need to know, which is the usage of SSS, SAS, ASA, and RHS. All right, so the names are side, 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 which means all the sides must be the same as said as this one. All right, so the side 1, 2, 3 must be the same. Okay, so this is a side, side, side group. Number 2 is the side, angle, side, which is side, angle, side. All right, side, angle, side must be the same. The third is angle, side, angle. Okay, seems like this must be the last video for today. My voice not going well now. So as you can see here, angle, side, angle. All right, they must be the same. And last but not least is the right angle, hypotenuse side. All right, so the right angle is here, the hypotenuse is here. All right, so if any of this condition holds for two triangles, these two triangles are said to be a congruent triangle. So if these two triangles are said to be congruent triangle, then given one length, one side at triangle A, you can predict, you can know what is the length of triangle B. Even if they are flat or anything, if you can find the same angle and same length, then you can know what is the last length asked for. And with this, we conclude this long video, I believe. To just a recap, in this video, I had introduced to you, all right, names of angles, all right, all these acute, obtuse, straight, reflex, and so on, similar triangle areas and volumes, all right, so you need to remember to use k squared, and k cubed. Last but not least, conditions for congruence, all right. I gotta be pretty honest, I don't remember my teacher telling me anything about congruence. It's either I'm not listening in class or anything. So I suggest you to read your textbook more on this, because I am really not too sure if I'm missing anything here, and I hopefully not. Please comment down below if you realize anything is missing right here. I'll be more than happy to learn about that. All right, so yeah, thank you for watching, and I'll see you guys in the next video where we are going to learn about a lot more angle properties uh, with rotational symmetry, line symmetry, and all those angle properties. And I believe that it's going to be a way longer video than this one. So yeah, I'm see you guys next time. Thank you for watching.